Hi, I'm Martin Tlaskal from FilmLight. This video is a re-recording of a presentation I gave on the 15th of May 2018 in our offices in London. In it, we're going to talk about the just released Baselight 5.1, which includes features like the boost range operator, new look operator, client view, and a whole lot more. We also look forward to Baselight 5.2, which will be released later this year, which includes a Relight tool, the ability to work on 360 video, and texture highlight. Finally, we finish with a look forward to Cryptomattes, an exciting way to exchange roto information between CG and grading. The first 5.1 feature I want to talk about is boost range. Boost range is an operator which takes standard dynamic range material and converts it to high dynamic range in a way which we think is more attractive than doing it naively per pixel. Before showing it to you, I just want to set the scene for our little project here. We have some sort of SDR material in Rec 1886 color space. We're monitoring in HLG, which is a high dynamic range space. And our stack color space is also Rec 1886, which means that when the SDR is converted to the display space of HLG, nothing's happening really. The highlights are kept in a very sort of low part of the tone curve. Now, if we convert our working space to a scene referred space, then suddenly our inverse TCAM DRT is applied, and what that gives us is an inverse DRT which expands the dynamic range. And you can see we do get a sort of brighter image, but the problem is that we get this sort of peaked, sort of plateaued highlight at the top end, which looks deeply unrealistic. So we'd like to do better than that, and we can by switching off the DRT, which is doing our sort of naive conversion, and using boost range instead. So we now insert boost range, and simply by dragging a slider to the right, you can see it will expand the dynamic range in a more attractive way. So you can see the image gets brighter, but you don't have that sort of clear, clipped, plateaued highlight. The reason it looks nice is because it's a spatial operator. It essentially decomposes the image into its frequency components and then recombines them in a clever way to get rid of that sort of like steppy highlight. Another shot, you can see a similar problem. Doing it naively gives you something which doesn't look very realistic. Using boost range gives you something which we think is much more plausible looking as a rendition of the original intent of the SDR shot converted to HDR. Should also point out that boost range works well with compressed 8-bit source data, where a naive conversion will increase compression artifacts. Boost range, because of the way it works by combining frequencies together, will actually synthesize new dynamic range, giving you a much better result. In Baselight 5.1, we've rewritten the looks operator to be color space aware. This means that when processing, we convert the image data from the stack color space to the looks internal working space and then back to the stack color space. The reason for this is it allows us to introduce what we call scene looks. These looks work internally in a scene referred space, which means that when they're applied, they don't clip HDR data like the old display looks did in previous versions of Baselight. We expect these looks to be used underneath a TCAM DRT, which does the actual work of tone mapping the image to the appropriate display. Let's see how this works. Here we have some footage under a TCAM DRT, and the whole image looks fairly neutral. There is no look applied. If we now add a look, you can see that we now have two sections, scene looks and display looks. If we add a scene look, like generic film, you can instantly see a more filmic rendering, in that the greens are sort of more olivey and desaturated, the yellows are richer and less pastel-y. We can add as little or as much of this look as we want, simply by dragging the level slider, so we can go back to the sort of more neutral look, or even put more of the look in if we want. We have different looks like Japanese film, which desaturates the highlights a bit more. earthy film, which desaturates everything and is a good starting place if you want something more gritty. And then we have a bunch of colorblind looks, which take out long, medium, and short wavelengths, which is really good if you want a sort of more stylized two-tone starting point. Let's move on to another shot. So again, we apply a scene look. Generic film, you can see it takes those sort of strong magentas, desaturates them, makes them a little bluer. And Japanese film perhaps keeps some more of those, that sort of magenta-ish tone, but also desaturates them. Earthy film desaturates the highlights a great deal, provides quite a different look. In this shot, one of the color blinds works really well. You can see here it completely changes the mood, but it still looks plausible. It's essentially removed all the blues, the magentas. What I want to talk about is simulation of a sodium light source. So here you've got something which is shot on the street, on this, what's supposed to be sodium street lights, but we've actually got quite a sort of moonlit look to it. So if we select a look which is sodium high pressure lamp, then suddenly you get a much more sort of distinctive sodium-y look, which we can dial back a bit should we wish to. So yeah, it means you don't have to actually shoot with a real sodium light. You can do it a reasonable job of it in post. The client view is used in situations where you have a VFX supervisor or a DOP or a producer in the room who needs to see metadata relating to the shot so they can take notes or that sort of thing. But you don't want that metadata up on the main display. The client view allows you to open up a socket and have their own laptop or another machine connect to that socket and display metadata. So it's pretty simple to switch on. You simply go to the client view menu in the status bar, turn it on. That opens up a port on the machine, on the Baselight. In this case, it's my Mac. And then simply the client switches to web browser, types in that address. Here it's localhost 8090, and that will give you metadata like take name, clip name. And then as we see stepping through the shots in this film, it's called Bully Parade, we see the client view updating in sync. Strip locking is a long requested feature because people sometimes want to prevent certain strips being modified. For example, maybe you have transforms coming from editorial which you don't want the colorist to be able to change, stuff like that. It's implemented pretty simply in 5.1. You simply open up your scene settings, go to the category groups tab, and in the section where it says lock parameter strips of category, you simply specify a category which you want to represent locking. And then in your timeline, you select the strips you want, add that category to them, in this case, lock. And then you can see that you see a lock symbol on the strips, and all the sort of parameters are unchangeable. You can't drag them with the mouse, and you can't change them with a trackball. So you're completely locked out from modifying them. Selection by strip type is also something that's been asked for a while, because often there are certain types of strip which you want to delete en masse or group grade en masse, something like that. It works pretty simply. You simply can do it in one of two ways. You can have the current strip go into the search menu and say select all, in this case, compressed gamut strips. You see they get selected. Or alternatively, there's a list, select strips of certain types. So in this case, we're going to select all the shapes. You often have to do repetitive tasks repeatedly on certain strip types, like, for example, shapes. Say you have a 2D grade in which you have to make stereo, which means you have to go to every shape and do something to it. So how do you quickly navigate between all the shapes? We can do that by navigation by strip type. It's pretty straightforward. If we select a shape, and then simply go into the navigate menu and go next shape strip, we'll go downwards through stacks, and then if you do it again, it goes on to the next stack. And you have a keyboard shortcut which is command up and command down. Transform alarm is a long requested feature. It's something which warns the colorist if they've transformed the image to no longer fill the output area. It's pretty simple. It's part of the display settings. So you go into the display menu, switch on a transform alarm, and you can also specify a color. I'm going to make it really red. And then I'm going to add a transform, and you can see that when I do that and decrease the zoom level, you can see it's very clear when I result in an image which no longer fills the output area. Baselight users have long requested the ability to put a scrolling list of thumbnails on the main display, either the projector or the client reference monitor, and that's been added in 5.1 as well. So you simply go into the display menu and specify either a 1x1 shot layout, which gives you a scrolling list, or you can also specify a 1x2 shots layout, which gives you that list and also the current image, which is great if you want to quickly sort of see the mood of a whole collection of shots together, but still see one of those shots in more detail. I now want to move on to Baselight 5.2, which is our next feature release. And the first feature I want to talk about is Relight. So some of you will remember, I'm sure, that Baselight 5.0 preview contained a Relight operator, but it never actually arrived in the release version of Baselight 5. And the reason for that is that we felt it was too techy. Everything had to be done in the point cloud view. You couldn't directly click on the image to position a light, and it just didn't feel like a grading tool. So we think the new version of Relight is much better, and I'll show you why. So the first thing is there's a simple macro to insert a Relight operator. You then simply specify a scale to determine the sort of units in which the operator is going to work, and then you just click on the image. And essentially what it does is it positions the light a target distance away along the normal from the surface of the image to the light. So you can see there it's very easy just to click on the image, adjust the brightness of the light, adjust the target distance, and just drag on the image. It feels much more like a grading tool. The second thing people wanted was the ability to precisely position a specular highlight. So often the reason to use an additional Relight node is to sweeten the image by positioning a specular highlight so that the image looks more glossy or something like this. And in the old version, in the preview, it was really hard to get the specular highlight exactly where you wanted. Now in Baselight 5.2, the Relight, you just hold down Shift when you're dragging, and it will position the light along a reflection of the vector from the surface to your eye, ensuring that there is a specular highlight at that point. So let's see what I mean. If I just hold down Shift when dragging, you can see there is a specular highlight directly under the mouse, which makes it very easy to sort of sweeten the image just by adding a specular highlight wherever you want it, animate it, that sort of thing, to get what you want, which we think people will make it much easier to sort of specify the intent of what the light should do. Next, spotlights. We've made it easier to adjust spotlights. So to convert a point light into a spotlight, you simply click on the drop down, it becomes a spotlight. It's easier to adjust the angle if you want it later on. So you can just make things appear like dragging a spotlight over it. Obviously, all the other settings are similar. You can specify a target distance. You can specify a cone. And you know how hot the cone is in terms of how much it falls, how quickly it falls off. So you can see it's a pretty standard spotlight, but it sort of looks nice in Baselight 5.2. The next thing we're going to talk about is area lights. Often a classic CG point light with that perfect little sort of circular fall off doesn't look that realistic, and you want it to represent a more realistic sort of practical light. So here you can see I'm dragging a square area light over the image, but you can adjust the shape of the light. So here I'm going to make it 3 times longer than it is wide. You can see that now you can see that rectangular shape reflected in the specular highlight. You can change the intensity and target distance and whatever in exactly the same as any other light, but that area light is now rendered sort of properly into the image. and perhaps in certain situations will look a little more realistic than just using a straight point light. So one of the new features in 5.2 is 360 video. So I'm sure you know what that is. It's where multiple cameras around a point are stitched together to produce a single stream of images, distorted, which represents a 360 view around that point. So one of the things that people using Baselight for doing 360 video has been just to give us a basic visualizer to allow you to play this stuff back and view it undistorted. So if you click the Panorama button for stuff which is marked as being 360 video, you can see that you can get a Google Street View style representation which is undistorted and looks plausible, so you can see the footage in context. Then the next thing obviously is modifying that image. Obviously primaries are easy, they affect the whole image, that's no problem, but for doing secondaries where you want to manipulate a certain area of that image, then you have to be able to deal with the distortion. So what we've done there is we've added a thing called a panorama sandwich, where you have two new panorama operators which essentially sandwich a bunch of operators which work on a camera view which is where straight lines are straight, normal sort of looking footage. So let's see how that works to apply a perspective paint to this building. So you can see here we use a macro to insert a panorama sandwich, and then we use camera control to keyframe and make sure that the bit of the image we wish to modify is in view the whole time. So you do the end, then we do the start, we make it look good, make sure that yep, it's in view the whole time. From here we can do pretty standard Baselight stuff. So we're going to add in a new layer, we change it to become paint, we construct a perspective plane, set up cloning parameters, that sort of thing, and then we do a pretty standard perspective clone. So we do the clone, and then we track it. So we define a tracking area, a bit larger than the area you want to modify, we track forwards, we track backwards. And now you can see, when viewed in this sort of output stage, you can see that we have a plausible clone on this 360 video image. And if we switch back to the distorted view, the equirectangular view, you can see here that that clone is correctly distorted to deal with it as the image distorts. So another thing you can use a panorama sandwich for is to deal with simple grading across seams. So you can see here in this footage, the people we most want to work with are this couple, but they're actually across a seam. So drawing a shape across that is not easy to make sure the edges line up and that sort of thing. So what we can do is just, again, go into panorama mode, and then we can add another panorama sandwich. Make sure that the people are in view the whole time. It's a locked off camera for them, so it's pretty easy. Don't really have to animate the camera at all. And then now we again do standard Baselight grading operations. So we simply add a grade, add a shape, draw a shape, blur it a little, and then apply a warming up grade to the image. So then we can see when we return, when we're in now sort of viewing the panorama footage, that it looks plausible. And if we return to our distortion view, you can see that we have that grade, that warmer grade on those two, and there's no problem with grading across a seam. So you can have as many panorama sandwiches in a stack as you like, depending on how many secondary grading operations you need. So we think it's a pretty good way to allow you to use any Baselight tool to grade 360 video. The next 5.2 feature I want to talk about is called texture highlights. It's a new operator which aims to help fix hard-edged, blown-out highlights in images. Let's see how it works. You can see in our example we have a typical hard-edged highlight with a distinctive flat top in the scope. Now, if we insert a texture highlights operator, we can see that by simply increasing the amount of the operator, we convert that hard-edged flat top into something a bit softer, which just looks more attractive. Now, we can change the size of the halation and also where it starts in the luminance range to get the effect we want. So we've made that a little bit softer. Now, it's important to point out this isn't just a blur. What's actually happening is that we're breaking the image up into its frequencies and then removing high-end frequencies in the sort of bright areas. This means that the darker hair where it's impinged on by the bloom, detail is retained and it continues to look nice. The next thing I'm going to talk about, which is a little bit further out, it's not in 5.2, it'll be in a later release, but we wanted to show it to people now to get people thinking and trying to get their CG artists to provide them Cryptomattes in their EXR files. So what is a Cryptomatte? A Cryptomatte was something developed by Psyops, a VFX company, and it is essentially an ID pass on steroids, where each pixel you can identify some identifier of the object that lies with that pixel. So in this car you might have, bonnet, door, stuff like this. And it gives you a very nice quality rotos without having to have individual roto channels defined for all these things. They're all encoded in a clever way in a Cryptomatte. Let's see how it works. So this car has crypto information in it. So if I just go into our Cryptomatte operator, I see now a list of all the various components of the car, and I can select multiple of them on at once. So you can see here I've selected the bonnet. I can then make that selection larger, or I can go in and grade that bonnet. So here we're making the bonnet go a bit green and a bit darker. And now obviously I want to expand that grade to the rest of the car. And the beauty of crypto is that I can have as many of those different parts of the car available to me as I like. So here I'm just going to do a sweep select of a whole bunch of operations. You can see it includes slightly too much, and that includes the windscreen, which we'll get rid of. It includes the front lights, which we'll get rid of. And it includes the logo, which we'll get rid of. So now we have a pretty good roto for that. And you can see that I can change the color, make it sort of a dark blue, which looks nice. But the beauty of Cryptomatte is the quality. A standard ID pass can't encode multiple sort of pixels, so you get sort of edge artifacts, whereas here you can see the edges are beautifully anti-aliased, and so the quality of grading you do through those rotomats is really, really good. So we think this could be a very useful way to interchange rotos between VFX, compositing and grading in the future.